We're coming out today for the on-demand webinar, Global Trend, Infrastructure Issues, No Borders. Today you'll be hearing from Bruce Rydbeck, myself, Colin McCorkle, and Mark DeHaan. And Bruce works with Life Giving Water International, which is a organization that's been working down in Ecuador for more than 40 years. Bruce has a wealth of experience and is really our connection to Ecuador and the communities in Ecuador. So we're super happy to have him here today. Mark and I are both with Safe Water in Ecuador. We recently went on the annual trip down to Ecuador. I work with Fishbeck and Mark works with Prine and Newhaw. A little overview of what we're going to go through in the presentation today. We're going to do a brief section on the need for potable water throughout the world and in Ecuador. We're going to give you a brief history of Safe Water in Ecuador and what we do and how we came about. Bruce is going to go into the technical details and challenges of a community called Miraflores, Cochabamba, and Bruce will expound on that. We're going to give you a brief history of the local in-country partners we work with, Codiince. They've been a wonderful organization to work with, all Ecuadorians, and Mark will give you some background on them. And then in the last section, we'll talk to you a little bit about how AWA can help and how we can best support the great work going down in Ecuador. So I'll start off talking about the global need for water. You know, Ecuador certainly needs water, and that's what we're here to talk about today, but there's a global issue as far as getting safe and potable water and access to water for people around the world. And what we don't realize and what we take for granted is that access to clean and potable water is a luxury. Having clean, clean water coming right to your tap, pressurized whenever you need it, is just a wonderful thing. But most people around the world, they really don't have that kind of access right in their homes. And almost 10% of the world population walks more than 1 kilometer for water. And water is heavy. You can see the children in this picture, they're carrying water on their heads. You know, they'll have to do this 3 or 4 times a day. And I've carried water 1 kilometer on my head and I was sore for a couple days afterwards. So it's really amazing. More than 40% of the world's population does not have piped water to their homes. You know, often there's a well in the center of the village or a local surface water source. And it's a lot of work to carry the water back and forth, and a lot of this burden falls on the children or the women. And you can see here this child here on the well. He's trying to pump it, and it's obviously not made for him. Used to see kids jump up and down to get it pumping, which they found was great fun, but you know, it is a lot of work, and it forces a lot of labor on the children. So in addition, 785 million people lack an improved water source. And what that means is that the water source is not protected from contamination. So you can get fecal contamination, other types of contamination, and even a well like this that might have been put in by an NGO a number of years ago, if it's not properly maintained, it can still get contaminated. So there's issues there. And beyond the need for access to water, you know, have it close by, or to have clean potable water, is the issue of water scarcity. So throughout the world, I mean, I've read books and articles about how water is the new oil. By 2025, half of the world's population will live in water-stressed areas. You know, we happen to be fairly water-rich in the U.S., so you know we don't really understand how the need for water and how hard it is when you don't have it. You know, we've seen a little bit of that with the droughts in California, and even the impact of that has been outsized, you know, from what we could even imagine. And there's also an estimate that lack of water or scarcity of water could displace up to 700 million people by 2030. You know, if there's no water where you live, you gotta leave. You gotta live. There's consequences to all of this. You know, not having potable water, often, you know, if water is not close by, it's more likely to get contaminated because you have to carry it for so long. Scarcity of water, you can't be picky about your water source. You know, if the water looks a little dirty today, it's the only water you got, so you got to drink it. And there's consequences to this. 1.6 million people are estimated to have died of diarrhea in 2017. These are often young children, old people, pregnant mothers. At-risk populations are the ones that die. So it's incredibly sad. And it's all preventable. Water, sanitation, and hygiene have the potential to prevent at least 9.1% of global disease burden. That's what the CDC has estimated. This is all preventable. So this is what we're trying to do. We're trying to bring clean water to people so that nobody has to die or no one has to suffer. And there is a lot of work being done right now, and there could be even more. There's a lot of NGOs out there, Water for People, Save the Children, World Vision. There's all these NGOs. There's governmental organizations as well, USAID, Peace Corps, that are offering direct aid to these disadvantaged countries. And often what these organizations will do is come into communities and construct the infrastructure directly. So they'll come in and drill a well, they'll leave it there and continue on. That's one way to do it, and there's other ways to do it as well. But there is work being done around the world, and now I'll let Bruce talk more specifically about the need for water in Ecuador here.
Well, good morning. This is Bruce Ridbeck, and I don't see my picture up there, but that's okay. What is the need for water like in Ecuador? It's been a great privilege for me to work alongside of Safe Water in Ecuador and have that wonderful relationship. And we are deeply grateful, all of us who work in Ecuador on this, and you'll hear more about that. But what does the water need look like in Ecuador itself? This, by the way, is Mount Chimborazo, our tallest peak in Ecuador. It's over 20,000 feet tall. Less than half of Ecuador's rural population have water at the house. For many of these homes, even when they do have water piped to the house, it's intermittent, it's of variable quality. And so it's a significant issue. For many of them, they're getting water in difficult spots. This is a water source for the community of Sul, which was a Safe Water in Ecuador project. So you can visualize the difficulty that this man had in bringing water to his home. Water sources are often significantly compromised, contaminated. Here you can see the pigs in the foreground, the algae. This was a pond where people also did their laundry, and it was the water source for Kislag Grande. Not only that, but the hillside on the right is where people carried the water up the hill. They had to carry the water more than 200 meters in elevation, substantially more than 200 meters, more than 600 or 700 feet in elevation going up the mountainside. So this is what it looks like hauling that water. It's a difficult task, not necessarily good roads. Often these paths are slippery during the rainy times, and they are not always paths that people can walk on easily or use an animal. On the left, you can see a woman who is demonstrating the traditional method that was used not too many decades ago, where the indigenous people used a ceramic flask, ceramic vessel to carry their water. And most often, it's the women and children that are the water haulers. I myself have carried water up this mountainside in Achuyay. I can attest that those 5-gallon cans do weigh almost a full 50 pounds. So it's a chore. And as Colin has said, if you're doing it several times a day, it's a time consumer. You won't have time for the gym, but you won't need the gym either. But also when that water is hauled in containers, it very often, most often, becomes contaminated before the people are able to use the water. This is not about laziness. These are very industrious, hardworking people in the rural sector. They know how to put together a work bee and all work together. And that's how water systems are built, with all manual labor. Doesn't quite look like the US, I know. Oftentimes there are miles and miles of pipe trench to be dug 4 feet deep. It's more than a little bit of work. And when we can, we have also gotten into the trenches with those people. It's wonderful to absorb their enthusiasm for that accomplishment. Concrete pumpers are not heard of in the rural sector. It's a bucket brigade for managing gravel and materials, getting them to where the concrete is mixed, or getting them to where the spring is located to protect springs. Concrete is mixed with a small mixer when we can get it to the site, but in many cases that's not possible. And so concrete itself is mixed by hand as well. These people are putting down their own hard-earned savings to build a water system, even though some of them still can be barefoot. When they need the money, they can sell an animal. They can somehow come up with the money that's needed, because water is indeed precious to them. So what is this? What is the need about? These people know how to work hard. They know how to put up their funds, but in the mix, they are not always successful. Studies indicate that only 13% of the rural water systems are in good shape and sustaining. They certainly need help to be fully successful. So what is it that holds them back? And I would say it's more the history, the politics, economic and social factors that keep them from the benefits that we enjoy. It was only about 5 decades ago, a little over 50 years ago, that these people received citizenship and liberation from a subservient way of life, from subservience. There were no public schools up until that point in time. In fact, it took until about 1980 before the rural school system actually functioned. And these kids, they are in Kapalis Pungo. They probably are a bit stymied in these days when virtual learning is necessary. I doubt that they get an internet signal to make use of that. And also, along with the lack of schooling, they had no possibility for getting water rights until about that time. So Ecuadorian communities are asking for help. It's the technical component that really is important and necessary to help them. What can be done, and what is AWWA Michigan doing to help them? So from here, Mark, go ahead, carry on in the presentation.
Thank you, Bruce. I'm going to quick go over what SWE has done and the history of SWE is connected to Michigan AWWA. In 1993, a student at Calvin College by the name of Scott Zastra wanted to complete his senior design project in an international community. He got connected to a missionary couple in Ecuador, who then connected him to the community of Calahuasig Grande. Looking for funds to help with the project, he turned to Michigan AWWA and got connected with Gordon Jones. And then seeing an opportunity to make a difference, Jones, along with Cheryl Topliff, started a section of Water for People that began working in Ecuador with Michigan AWWA. Eventually, Water for People stopped working in Ecuador, but Michigan wanted to maintain that relationship and formed Safe Water in Ecuador. To date, over the past 27 years, SWE has helped 17 communities build water systems and chlorine dosing systems to provide clean, potable water for people in Ecuador. The second community that SWE assisted was Miraflores, Cochabamba in 1999. On the right, you see a photo of their chlorination building and top reservoir. Bruce will highlight the Miraflores, Cochabamba system later in the presentation, and you will see how this system that SWE helped fund has had a multiplying impact in Ecuador. SWE has also teamed up with Rotary International on a number of projects, one of them being the community of La Pacifica. On the next slide, you will see the photos of the La Pacifica water source. The top left is the water source before spring protection, and then on the bottom left, you'll see the improved water source. And then on the right, one of the taps that was installed with the system in La Pacifica. Here you see a photo of Efrain and Martin, two of the engineers in Ecuador, investigating the reservoir overlooking the community of Castug Tungurawilla, a community that SWE assisted in 2010, and I'll share a little story about that in a moment. And then in 2012 and 2013, SWE helped the community of Yanacocha, which can be seen on the right. And then on the left, you'll see one of the typical taps that's installed. It's got a meter on the top to track water use. That's just one of the taps that's in the community of Yanacocha. In 2018, SWE donated chlorine dosing pumps and testing equipment to the community of Santa Juan Grande. You see a photo on the right there with myself, Greg Marker, and Jessica Howard. Greg and Jessica work for OHM, and the three of us went on a trip in 2018. And then in 2020, this year, SWE has donated funds for the pumps at the San Antonio de Quito system. On our trip at the end of last October, Efrain Marocho presented a proposal to SWE for assisting San Antonio de Quito, which Colin and I accepted. And that's a photo of us right there. Along with the building of the systems themselves, SWE has also funded training seminars for system operators, as well as the Circuit Rider program, a program that follows up with communities on a quarterly basis. This can be as simple as having a discussion with the system operator and doing some water testing, as you see in the photo on the top right, or it could result in some more substantial work. As I mentioned on our trip in 2018, we visited Castug Tungurawilla, and there we replaced a pump and a motor in their water system. You'll notice that a successfully operated system like Castug, the entire community has bought into making sure the system operates smoothly. I can't say I've ever seen a resident jumping in a trench to help with a water main break in the United States, but in Ecuador, it truly is the entire community that keeps these systems maintained and well run. Bruce will now share the story of the Miraflores Cochabamba system and how an idea from a SWE member helped with a very specific technical challenge.
Well, I'd like to tell you about Miraflores Cochabamba after the exhilarating result in Calahuasig Grande. It actually took a few iterations in that project to get it right. But we took the SWE group to Miraflores, Cochabamba, which is located on a mountain ridge at about 12,000 feet. Just to give you a picture of how it is to get around on the mountainside, this was one trip that we took with SWE, a little bit more recently, and another road. But the road in those days up to Miraflores, Cochabamba was not too far different. So that was part of the challenge. It was a rainy day, in fact, when we went up there. And actually, prior to going up there with SWE, I had gone up there with my wife, and she had an opportunity to interact with women up there, wonderful folks. And just to remind you folks in Michigan that this is not quite as flat as Michigan. These are the Andes Mountains. And that is part of the technical challenge that you'll hear about, not just driving around, but also the engineering has substantial technical challenges with it. And this is an actual picture in the community of Miraflores, Cochabamba. When we arrived in the community knew we were coming. They knew that they wanted to communicate their story to us significantly. And they knew that they wanted to cross that language barrier successfully. So one of the things that always happens in Quechua communities is food. These people are very hospitable, and their local delicacy is roast guinea pig. Cuy is, as it's known in Ecuador. And a special plate, of course, is roast guinea pig and boiled potatoes with onion and peanut sauce to boot. It's a great meal. I'm sure you'd all love it. Along with that, very often comes fava beans. Fava beans, as it is in English, they're somewhat like lima beans, but they need to be squeezed out of that leathery outside shell. And a good meal always includes lots of soup. If you're lucky, you will also get a piece of guinea pig, cuy, in your soup. So a meal was part of that communication. But these people also explained their story. They had worked for more than a decade to build a regional water system, basically with very little benefit. The water came from a long distance away in the mountains, and that water system served 17 communities, but it was beset with problems. Oftentimes, they would have debris coming out of their spigots, or small frogs, worms, and sometimes horrible tastes. In fact, there was a period of time when the water was so bad that the people went to the intake to see what the problem was. And in the intake, they found a dead burro, if you can imagine that. So their water system itself, the regional water system that they were struggling to maintain, was a health hazard in and of itself. And even at that, they only received water for 2 days a week, no water during the summertime. They were desperate for some help in doing something better. Any water that they would use for domestic consumption had to be taken from a spring down at the level of this river, actually on the other side of the river. So they had to cross the river and fill up their containers with water. And then, of course, haul the water up the mountainside. Actually, this is a fairly level part of the path. I don't think the path could be properly negotiated with with animals. So most often it was carried on people's backs. The homes are at least 1,000 feet higher than where that river is located. So if you can picture doing that every day, it's an arduous task and made life more than a little bit difficult for them. So they acted out a theatrical presentation for more than an hour. They were doing it in the rain, the light sprinkling rain. We were under a roof watching. Here in this picture, you can see some of the people from the community as well as a couple of visitors who were there with us on that particular day. But it was very convincing to the Safe Water in Ecuador group, and they took on the project. There were numerous technical issues. Here you can see where their spring is located. The only springs where they had water rights were 3 miles away, 5 kilometers, on another mountainside on the other side of the river. So those springs needed to be captured and the water transported all the way to the community. The springs were actually almost 50 meters higher than the community itself, but nonetheless, the feed line needed to cross that river valley. There was a total flow between 2 small spring areas of 12 gallons a minute. Here you can see one of those spring areas after it was protected. The spring is in this slide area where the slope is obviously failing. And just behind that concrete wall is where the spring water is collected, subterranean, in a rock and gravel filter pack, so that it runs very clean to the community. And there below the concrete wall, you can see gabions to help stabilize the whole area. There are the 2 Quechua men who supervise the spring protection, standing on that concrete cutoff wall, which goes substantially down into the ground to cut off the groundwater flow so that all of the water, spring water, enters into the spring collector. Another challenge that was faced is crossing a mountain road that's on the other side of that river. You can see that road, which was highly traveled. All of the trench was dug by hand because of the pipe grades, etc. The pipe trench on the downhill side of that road crossing was about 10 feet deep. We blocked off the road for a little bit over 2 hours. People were honking and not too pleased with us, but they dug furiously and were able to cross that road successfully. These people know how to work and how to work hard. They do their work, as I mentioned, in work bees, what's called a minga in Ecuador. Even the women work hard. Here you can see a picture from another project where women are carrying large stones. They have no reluctance to put their shoulder to the plow, as we might say. And oftentimes women are working with a child on their back, not an infant. This child is probably a couple of years old. So that adds a little bit more weight and challenge for them while they're shoveling gravel, loading a mixer, or whatever the work might be. And then, of course, there was the challenge of crossing that river. A subterranean crossing was decided instead of a pipe bridge. We could see that other communities had tried to cross the river with a pipe bridge and were having significant issues with floods, with cattle damaging their pipe, etc. And we wanted a long-term solution. So the people put in a sleeve pipe encased in concrete, 1 meter underneath the bed of the river, so that when we arrived with the actual pressure pipe, we could just snake the pipe right through underneath the river. Also, it was necessary to again use gabions to stabilize one of the riverbanks from erosion. The pipe trench is in much more fragile soil, which would easily erode. Here you can see a cross-section of the feed line from the spring going up to the community. The red portion of that cross-section indicates where high pressure pipe was needed. Normal pipe in Ecuador is rated up to 1.25 megapascals, which is about 175 PSI. And the river itself is 350 meters lower than the top reservoir, which calculates at about 500 PSI. So in order to conquer the pressure issues, we needed special high pressure pipe, which had to be imported. One of the Safe Water in Ecuador members helped us to home in on using fiberglass pipe, and 2-inch fiberglass pipe, which came in 30-foot lengths, was used for about a little over a mile. I believe it was a bit over 6,000 feet of pipe in the project. But here you can see that even 2 people could easily carry 1, even 2 lengths of pipe on the steep mountainside. This was not a challenge for them. We realized that in another project that was built not far from where we were located, a government project, the design had been to use ductile iron pipe. And a couple of people were killed in that project, moving the heavy pipe over the mountainside. So we were quite pleased with that pipe selection. It worked very well. The joints were fastened by threaded and also epoxy welded joints. It was a very good design of pipe. We worked together as a team, so people would be cleaning the pipe ends and then covering them, coating them with epoxy and turning it together. It's a different type of thread that with a cup less than 2 turns would be all the way home, and even wet, those joints could not be backed off. They were very, very secure, and we have not had any problems with that pipe since that time either. In order to do this successfully, since the epoxy was only good for 15 or 20 minutes, and we had a limited number of epoxy kits, we had a whole army of people carrying pipe into the horizon almost, or into the mountains, so that with several setup stations, we were able to do most all of the epoxy pipe, the epoxy welded joints. And here you can see people working down towards the river location. By the way, the pipe was, you could say, was donated by Safe Water in Ecuador. About half the project cost was in that pipe. It needed to be transported to Ecuador in a 40-foot container, since They were 30-foot lengths. So the shipping itself was a significant cost. And of course, the water needed to be transported up to the top reservoir. Here is the top slab of that reservoir being poured. And there is the final project, the product, the reservoir as it exists today. And when the feed line was completed, I was not actually there, but people tell me the story. They were so excited about having water actually come up to their community. They were compelled by curiosity to start a bonfire. They waited all through the night until the water came in the early morning hours. And amazingly, there were a few doubters in the group after working months and months, more than 100 days of labor on the project. When the water finally arrived, there were a few people who said, "Wow, I never thought this was going to work." On that tank, there's a dedicatory plaque, including the Safe Water in Ecuador group, which at that time was known as Water for People, Michigan section. And the mission that I was with at that time, HCJB, Community Development, and a church that sent a team to Ecuador to work with the community on the project, and also donated. And also on that plaque is an interesting promise from the prophet Isaiah, where God promises to complete. And God certainly answered their prayers and responded to their concern, their prayer, as well as all that hard work that those people put into the project. One of the 114 homes, families that participated was Efrain and his wife Simona. At that time, they had a young son, just a baby at the time. But he worked for more than 100 days to put in his spigot, which you can see in front of us there. And he, of course, is extremely proud of that. Efrain is now the director of the ministry, which is being done, being implemented by Ecuadorians, actually indigenous Quechua people. So he has been a wonderful man to work with, and very proud of the ministry and the accomplishments being made in communities. On your left is Martin, a German engineer who's working on our team. He's living in Ecuador with his family, wife and 3 children. Myself on the right. Until last year, my wife and I were living in Ecuador, and it continues to be wonderful for us to work with that team. I'm going back to Ecuador as often as I can to be a help to our group down there, which is providing the technical help to the communities and helping them do the design work, the survey work, all that's needed to help them be successful. So from here, Mark will take on the presentation again. Thank you.
Thanks, Bruce. As Bruce mentioned, there are a couple of local Ecuadorian indigenous organizations that now do most of the project work, Codeínce being one, and Causepac Yacu being the other. These organizations are run mostly through Efrain. Efrain is the director of Causepac Yacu and Codeínce. And so you see him with Lady Yepes, who's a Colombian engineer here doing some water testing. On the next slide, you'll see a photo of Efrain and his wife Simona. As Bruce mentioned, he lived in Miraflores, Cochabamba. And after seeing the benefits that the water system brought to his community, he wanted to be part of helping other communities build water systems and improving the lives in those communities. So Efrain earned a degree in construction technology, as well as biblical studies and a master's in theology. You can see him here in the community of Achiai doing some work on the well tank, just fixing some cracks and some voids there, doing a little bit of drilling, and then they later filled that with epoxy. That's a photo from our 2018 trip. Efrain is often the primary point of contact with the communities, as he speaks both Quechua, which is the indigenous language, and Spanish. Here you can see him with the community of Senecuan Grande, just talking through the benefits of, I believe he was discussing spring protection here. And then on that trip, he also discussed chlorination of the water system with the community there. And of course, all these decisions are made as a community. Efrain is highly regarded in the communities, and in 2 decades of work has made a lasting impact. As I mentioned, Efrain is the director of Kausepak Yaku and Kodiinse. These organizations were formed in 2009. Kausepak Yaku stands for life-giving water. And then Kodiinse is an acronym which stands for Corporación de Desarrollo Integral Socioeconómico, or Corporation of Integral Social Economic Development. And so both of these ministries, as Bruce mentioned, are run by indigenous families, mostly from that Miraflores Cochabamba community. So as I mentioned earlier, quite the multiplying impact from a SWE project. There are some expats that work with these organizations. On the far left, you see Chris and Samantha Vischer. They are from California, and they live in Ecuador along with their 4 children. As Bruce mentioned, Martin, who is next to them, and his wife, Julia Heinrich. They are from Germany, and they live in Ecuador with their 3 children. Cesar and Nancy Cortez are next to them. They are from Ecuador. And then on the far right, you have Bruce and Cherith Ridbeck, who until about a year ago had lived in Ecuador for about 40 years. Along with those 4 couples, you have Lady Yepes. She is a Colombian engineer standing there in the white, and she does a lot of work with the communities. And then on the far right is Braulio Morocho, who is Efrain's son, and as Bruce mentioned, was just a baby when that Miraflores Cochabamba system was being built. But he recently received his engineering degree and is now working with Kodiinse and helping with design work and construction implementation. So prior to starting a project, just to give you a quick idea of how this process works, Kodiinse has several discussions with the communities, making sure that the community is committed to a successful project and a sustainable system. Part of these discussions do involve the money that is required, and Kodiinse requires an upfront payment from these communities. It's not just the word of the communities that they require, but also this financial buy-in to make sure that these communities want a sustainable system and will do the work to make sure that that system works for years to come. There are many examples of broken systems in Ecuador as organizations step in for a short period of time, build a system, and then leave. You can see here in this photo, water pipe run above ground, wrapped around power poles. These sort of situations are more common than you think, and as Bruce mentioned earlier, only about 13% of water systems are sustainable. And so that is something that Kodiinse and Kausepak Yaku really want to focus on, is making sure these systems are sustaining. Team members from the 2 organizations are directly involved with collecting survey data, using a total station system, and then they will also assist the community in securing local government funds to help that project moving forward. Sometimes offers are made to students to help with these projects. This is a photo from my senior design project in 2015 in the community of Apatug. We spent about 3 days collecting survey data, setting up on rooftops, and telling a couple of community members to run around from house to house with prisms as we collected that survey data. There are also opportunities for summer internships for students to work with these organizations. On our 2019 trip, we stopped in the community of Galtes. You see Braulio standing there with the white hard hat on. He was directing the construction work happening in Galtes. They're connecting the water pipe to the underside of a bridge. The community of Galtes consists of almost 600 families, and the project required 80 kilometers of water main pipe. And so you've seen in Bruce's part of the presentation just the work that goes into building the system. So for 600 families to hand dig about 80 kilometers is really incredible. Now Colin's going to talk about how you can become involved and participate in the work in Ecuador.
All right, thanks, Mark. So yeah, you've heard all these wonderful things that Mark and Bruce are mentioning, and now you're wondering how you can get involved. Well, this section is for you. So pay attention, and we'll move from here. The first and easiest way to get involved is you can join our committee, Safe Water in Ecuador. We could always use more members, you know, from more diverse backgrounds. We'd love to have some people who have more hands-on experience. We're mostly engineers. And, you know, Safe Water in Ecuador, we have a long-standing relationship with local Ecuadorian organizations and communities, as well as with Bruce. Bruce is sort of our main go-between to these Ecuadorian organizations and communities, Codiense and other things. And the committee, we provide fundraising, and we also do the annual trip to the communities. When you join the committee, it doesn't mean you have to go on the trip. So that's one thing that, just to make clear, you know, if you don't have enough vacation, or, you know, you just don't want to go down there, that's okay. You can provide a lot of help otherwise. So, and beyond the fundraising and the annual trip, also technical expertise. So, you know, at times Bruce or Codiense will run into technical issues which they are not familiar with, you know, and AWWA, you know, we are familiar, as a whole, we are familiar with everything in regards to water, you know, pumping, distribution, everything else, chem feed. So what we can really provide beyond fundraising or a trip down to Ecuador is technical expertise, you know, and it runs the gamut: submersible pumps, chemical metering pumps, some reservoir design, hydraulic modeling, chlorine testing. I mean, you can see on the right there's some pictures of some of the pump stations in place. Also help with electrical controls could always be used as well. And we would especially love to have some hands-on help for the annual visits. There's a number of pumps that are installed in these communities. And anyone with experience in pump repair and installation could really provide a big help to us when we do our annual visit, and talking through maintenance and looking at how the pumps are installed, and sort of just your general experience. So this could include plant operations or maintenance staff. If you work on pumps, you know, every day, you could use some help down in the annual visits. And also electricians are controls experts. You know, there's pump panels for all these different pump stations. So, you know, if you could come down and provide some of your experience and expertise, we would love that, because most of us on the committee are engineers, and you know what happens when we get in the field. Not much is the answer. So I'll continue on. The other way you can help is Calvin College does a number of senior design projects, as Mark had mentioned. He worked on one himself. And I know that they are often looking for technical support to those senior design groups. I know my direct boss was working for, or was helping one of these groups one time, because they were in the office all the time bugging him about it. And you know, as part of that, if you want to go down with the Calvin group and get eyes on the project itself, I think you would have the opportunity to do that if you'd like to. So finally, I wanted to talk about, so this next project that we're funding, or that we've already provided some funding for, is San Antonio de Quito. It's a community down in Ecuador that we are providing funding for the pumps in the pump station. The pump station's already built. You can see it there on the left. We were unable to get into it at the time because it was padlocked, but you know, we were able to get a picture of the outside anyway. So this next project that we're funding is to supply pumps to that pump station and the installation costs there. And this pump station will pump water up to reservoirs up on the hill, which will then provide potable water to more than 358 families. And over the right is some pictures of the community. We wanted to go a little more depth on the technical issues and sustainability issues that Bruce has been running into and has asked for help on. So if anything perks your interest during this, be sure to contact Mark or myself if you'd like to provide help. And we can put you in Bruce and get a little more detail to you and see if you can provide some technical help to Codiense and Life Giving Water International down in Ecuador. So I'll just briefly touch on each of these. And once again, please talk to myself or Mark if you think you have a good solution here. There have been some issues locating leaks in PVC or plastic buried pipe. There's not necessarily an easy way to know when something's leaking and it's buried, and it's especially when it's plastic. So if anybody has, you know, an inexpensive and sustainable solution for trying to locate these leaks, and you're talking about small diameter piping, you know, 1 to 3 inches. So often a leak is not easy to detect. It's not exactly spewing out of the mountainside. So if anybody could provide a little technical help on that. In addition, flying drones in mountainous areas. As Bruce said before, this isn't Michigan, you know. It's once you get down a mountain, you're going up another one. So it's a lot of elevation change. And Codiense and Life Giving Water International do fly drones in the region. And they have had a lot of crashes. So if anybody has, you know, sort of experience in flying drones in mountainous areas and how to avoid some of that, that would be great. The reservoirs that are in almost nearly, well, probably all of these communities, we would like some structural analysis of what kind of earthquake they could handle, and maybe some design tips if you think there's a way to improve on that. So we'd be looking for that. You could see a picture of the reservoir on the right there. Typical circular reservoir. In addition, there's been some issues. So often the pump stations that are in these communities are submersible pumps in a clear well under a pump station. And we've had some issues in identifying the submergence requirements of these pumps. It seems you can't get a straight answer on that. So if anybody has a lot of experience with submersible pumps, we could use your help. And then the programming installation of reservoir level controlled pump panels. There have been a number of issues in communities with trying to control based off of level. And really at this point, things are run more off of timers. But if anybody has experience with long runs of control wiring and the issues therein and possible solutions, we might need your help on that. Identifying and purchasing a reasonable and robust chlorine residual analyzer could be a big help to Codiense and Life Giving Water International down there. In addition, there have been, so SWE has provided hot chlorine units to test on the chlorine residual in a number of these communities. And there have been some issues with trying to get replacement pieces and parts where the chlorine kit's still in good shape, or on how to get things to last a little longer in those chlorine kits. Any sort of expertise or input on that would be great. Also, regular and submersible and metering pump maintenance. We have the O&M manuals and things like that, but anybody with experience in maintaining these pumps, you know, that could be plant operations, maintenance staff. I know work on these kind of pumps every day. It's blue-white metering pumps and then Franklin submersible pumps. Just getting an idea of what needs to be done daily, weekly, monthly, the difficulty of the job. Cody Insay often goes around to the different communities and does work for them, and they can probably do a little more difficult maintenance, but there's also local operators. So if you can give us an idea of the difficulty of the maintenance task as well as how often it needs to be done, that'd be very helpful. We've also started to talk about, you know, acquiring some AWWA manuals for Cody Insay as a wonderful guide. You know, I have on here water chlorination, you know, that's very necessary. Polyethylene pipe. And if we can always translate these to Spanish if they're only in English. But we were thinking about getting some of these manuals. You know, I know at my firm, we just have a stack of these manuals, you know, and sometimes it's great to be able to pull that off the shelf as a reference. So we were looking at acquiring some of these for Cody Insay and maybe the possibility of donating old editions. You know, some of the new editions have some things that probably don't apply to Ecuador anyway. So even if a firm has an old edition that's been replaced, we would love to be able to bring those down as a great resource for Cody Insay into the future. And once again, like I said at the top, if any of these sort of perked your interest and you said, oh, I know a lot about that, please contact Mark or I. We'll have our emails at the end of this presentation. So. All right, the last little bit I wanted to talk about the annual trip to Ecuador. This is a lot of fun. Mark and I went this past time. I talked to Big Game about, it was just the two of us, so I talked to Big Game about getting a picture of us on tandem bicycles or on one of those rail carts that only require two people. But my Photoshop skills are lacking, so I didn't get that in here. But I wanted to talk briefly about the benefits of the annual trip. You know, you get to see firsthand how much these communities really value water systems, which is something you don't see in the States as much. You know, the only time we think about water is when it doesn't work. But you see how, you know, how happy these people are to be able to put their time and effort to get water to their homes. And it's really amazing to see, you know, just the importance of water to these people. And you get the opportunity to see the work firsthand and to meet all the people. You know, they're amazing people up in these rural areas who are just living a totally different way of life. The other great benefit of coming on this annual trip is you get to connect with the staff of Cody Insay and Life Giving Water International, just amazing people who are just basically completely selfless, giving of themselves at all times to try to help these communities get water. You know, it's encouraging to see that sort of selflessness and drive and passion going into these projects. I mean, it's sort of gives you hope for the future of things here. And you also get to learn some things. So in Ecuador, water systems are thought about very, very differently. You know, it's a lot of smaller diameter things, small flow, a lot of elevation change. There's the way the water system's designed, it's all about sustainability and keeping things running out into the future. So it's interesting, and it's a different way of looking at it than we typically look at it in the States. So I think it's interesting technically as well. And again, as I mentioned, you know, these communities, they've invested a significant amount of time and money in these projects, but they're often isolated in not in the islands, in the mountains, often in the mountains, and you know, they don't get a lot of people visiting necessarily. So us coming down and offering encouragement, you know, and saying, wow, you've really done a great thing here is of a benefit to them. You know, they get to see that people coming down from America really appreciate what they're doing and think it's a wonderful thing. So. Finally, yeah, this is, I mean, Ecuador's beautiful. So if for nothing else in the trip, you want to go just to see stunning vistas all around you, everywhere you go, you know, you can close your eyes and take a picture like one on the right, anywhere you're at. I mean, it's a beautiful, stunningly beautiful country. It's amazing. It's a unique experience. You get to see a different culture, a different way of life, you know, sometimes a simpler way of life. It's kind of relaxing not to have the hustle bustle that we have up here in the States. And there's time for some sightseeing. On the left, you can see the Basilica that's over in Quito. It's absolutely gorgeous, and there's some really great sightseeing to have there. And there's no need to learn Spanish to go down. I don't know Spanish, and I went down, and it seemed to work out all right. As long as you don't mind being laughed at a little bit when you do try to speak Spanish. So yeah, but we'd love to have more people on the trip. It's a great experience, and it really encourages you to give more of yourself if you can. So, all right. So thank you guys for listening to our presentation here. You can put questions in the chat, I believe, if you have any, and we'll answer them as time goes along. So.